Okay, so again, we don't have anything new to learn. We're just doing review, but we're going to take this 7.5% interest and we're going to compound it monthly. The way you do that is you take the 7.75% interest, always written as a decimal. To compound it monthly, you divide by 12. There are 12 months in a year. And to make the money grow, to create exponential growth, you do 1 plus. Okay, growth is 1 plus, decay is 1 minus. And then the 12 is because of the compounding monthly. So if you calculate that, this is your value B right here. There's a point right there. It's kind of hard to see the point, but that's a 1 point. There we go. Okay. And then since we are compounding monthly, the exponent, X, is going to be counting the number of months. So how much money is she going to have in 7 years? Well, she's starting with 5,000. There's the multiplier we just calculated. 7 years is the same as 84 months. So you can type all of that into your calculator and you can figure out she's going to have about $8,586. So the answer to the question, will she have enough money? Yes. She is trying to make sure she has at least $8,000 in 7 years for college. So yes, she will have enough money. Okay. 8 years ago, Rudy thought that he was making a sound investment by investing $1,000 into this stock. Unfortunately, his investment depreciated. That means it's losing money. It loses 15% each year. So losing is decaying, is the opposite of growth. We do 1 minus the percent. He's losing 15%. So his multiplier is 0.85. So here is his scenario. Starts with 1,000. He's losing 15% each year. That's his B value. And this is going to happen for 8 years because it says 8 years ago he bought this stock. How much is it worth today? Today is 8 years after he bought his stock. And yeah, that was a really bad investment. So he had $1,000 8 years ago, and now he doesn't even have $300. So this was a very bad investment on his part. Okay, we have a bank here. The Bank of Mo Money will let you pick one of these 3 options, and you are going to invest your money in this bank for 3 years. So option 1, 8% simple interest. Simple interest, you just multiply your money by 8%. That gives you $96. So the bank is going to give you $96 every year. So you end up with a linear equation, or $96 for 3 years added to what you started with. So you started with $1,200 and the bank's going to give you $96 every year for 3 years. Okay? And you end up with $1,488. Okay? Option 2. Compounding. When you compound the interest, it's exponential. And the compounding just means you earn interest on the current amount of money, not based on the original amount. So we have to continue calculating the interest every single time. In this case, every single quarter. So you are earning 7.87%. There's the percentage. Quarterly, there are 4 quarters in a year. Your money is growing, so you do a 1 plus. So 1 plus for growth, 1 minus for decay. So 1 plus, quarterly growth, there's the B value. 3 years, quarterly, 3 years is 12 quarters. So this money is going to grow for 12 quarters. So starting with $1,200, there's your B value, 12 quarters. Type that all into your calculator and you're going to end up with $1,516.08, which is better than option 1 and actually turns out slightly better than option 3. But here's option 3. So option 3, 7.75% interest compounded monthly. So you take your interest, you compound it monthly, 12 months in a year. 1 plus. So you do 1 plus, and there's your new interest rate. That is now monthly. There's your B value. 3 years. Monthly is 36 months. So make sure that the exponent matches the time period. It's months. 3 years measured in months. So $1,200, there's your multiplier, and you're going to get your interest paid to you 36 times. So you're going to get compounded 36 times, and you end up with slightly less money than option 2. They're very, very close though. I mean, literally it's a difference of $4. So you could argue that maybe it really doesn't matter if you're going to quibble over $4, but technically option 2 does give you a slight advantage over option 3 at the end of 3 years. Okay, number 4, you bought a used car for $25,000. The car depreciation means loss or decrease. So we are decreasing the value of the car by 12% per year. So the car is losing value 12% per year. 1 minus represents a decrease. Decay, depreciation, those are all words that we use to represent a percent of loss. So losing 12% gives you a B value of 0.88. Started with $12,000 or $25,000 worth of car. 0.88 is your B, and we want to know how much is it going to be worth after 4 years. There's no compounding or anything, it's just years. So 4 years, that's what the car will be worth in 4 years. Okay, next page, we have Leah, who is collecting Shopkins. And she started with 5 in 2015. So right here in 2015, year 0, because you can start counting year 0 whenever you want. I'm just going to start it in 2015 because I know what year 0 is in that case. I'd rather start with my y-intercept. So year 0, she starts with 5 Shopkins. Today, which is literally 2020, that's what today is. So that's 5 years later, she has 1,215 Shopkins. Okay. Now the advantage here is this is A. So I can take the equation y equals A times B to the X is our exponential equation. And I can put this in for Y, this in for X. This is my A because it's the y-intercept, and I can solve for B. So that's what I did here. Y is 1215, A is 5, and then the X is also 5. So now I solve this. I divide both sides by 5, and you get 243. I have a 5th power on there, so I would take the 5th root of 243 on a calculator, and you actually get 3. So that just means she's tripling the amount of Shopkins she has each year. So every year she triples her collection. So it just said write an equation. So there's her equation. When it says write an equation, make sure your equation has an X and a Y in it. Without the Y, that's not an equation. An equation is something equal to something. That is now an equation. So just be careful on next week. If it says write the equation, this is the general equation here. And then from here, I could ask you how much will she have in 10 years, or whatever, then you can plug numbers into it. But if it asks you for an equation, make sure that you write an equation. So an equation is an expression with an X and a Y in it in the form of Y equals A times B to the X for an exponential. So same thing here. Write an equation for the exponential functions with the following points. So 0, 6, that's A. Whenever there's an X of 0, that's A. So A is 6, and then I can use this for X and Y. So back up to this, Y is 384, A is 6, X is 3. So in other words, if one of the points is the y-intercept, use that as A. So this is my A, and this is a other point that I can just use for X and Y. I could use this for X and Y, but I'd rather use it for A because I know I need to find A, and I already know what A is. Plug it all in. Divide by 6, you get 64 equals B to the 3rd power, and then you do a cubed root. So I calculated that by a cubed root or a 3rd root, same thing. B is 4, there's my A, there's my B, there's the equation. It said just write the equation. Didn't ask you to find anything about the equation, just write the equation. Part B, okay? Part B, I have 2 points, but notice that neither of them are A. There's no zeros here. So I don't know what A is. So the only thing I can do is plug this in for X and Y and also plug that in for X and Y and create 2 equations, create a system. Of course, you can also use the table method. I did equations here, but you can do this with the table method if you prefer. So I take the bigger points here. There's my Y, there's my X. So Y equals A times B to the X. I do the same thing here. Y equals A times B to the X. X is 2 here. The A's eliminate. I divide and I get 25. And B to the 4th divided by B squared. 4 B's on top, 2 B's on the bottom. That leaves me with 2 B's or B squared. So 25 is B squared. Square root B is 5. And now to find A, I plug back into one of these. I used this one. 175 equals A times B squared. B is 5. B squared is 25. So this becomes 25A. Divide, A is 7. Okay. And then this one, it's the same thing, just with some uglier numbers. So the numbers here just don't turn out as pretty, but it's still the same thing. This, f of 6 equals 12. That's a point. 6 is x, y is 12. Here's another point. X is 15, y is 23. It's just function notation. It's just another way of describing points. So this is an x, this is a y, this is an x, this is a y. So I plug this in. 23 equals a times b to the 15th. Plug that in. 12 equals a times b to the 6th. Divide. It's not pretty, but I divided it. Eliminated the a's. 15 b's on top, 6 b's on the bottom. Cancel them out. I'm left with 9 b's, or b to the 9th. Calculator. Do the 9th root of this, and there's my b value. I can find a by going back to one of these and substituting in. So I chose this one. 12 equals a times b, which is right here, to the 6th power. So 12 equals a times b to the 6th. I calculated that on my calculator, and then I divided it. So in other words, to get a, I have to take 12 and divide it by 1.07496 to the 6th power. And that gave me an a value of 7.771. So there's my equation. And then it said, what's f of 20? That means take your equation, plug in a 20, and you get about 33. Okay, and again, if it asks for an equation, make sure your equation has an x and a y. F of x is the same thing as y. So you can have an f of x if you want, but an x and a y makes an equation. And then once you have your equation, you can plug things in there and solve as requested. And then the last one was to draw graphs. Okay. Now I did not draw tables here, but you absolutely can. If you wanted to do this with a table, if that is easier, you can set up a table here. Got my x, got my y. Find my y-intercept, which is 3. So I know I've got a point at 0, 3. Okay. The 1/2 tells me what's happening. As I go down the table, I multiply by half. Half of 3 is 1.5. And then my next point, half of 1.5 is 0.75, etc. To go up the table, if I'm multiplying by half, to go backwards, I divide by half, which means multiply by 2. Dividing by half is the same as multiplying by 2. So I can go backwards by multiplying by 2. And you'll see that I got a point up there at -212, -1.6, 0.3, 1.5, and then I just have to start approximating once we get close to the x-axis, because we expect an asymptote on the x-axis. So these just get smaller and smaller and smaller. you can kind of just eyeball it there. You really can't graph them accurately. Same thing on this one. If you want to do a table, then do a table. X, Y. Y-intercept is 2. So put a point in your table at 0, 2. The 3 tells me that I need to triple my Y values. So my next point, multiply that by 3, is going to be 6. My next point, multiply that by 3, is 18. And I really don't have any room on my graph to go further than that. Even the 18, I had to kind of, it went off the graph. Go backwards. If I'm multiplying by 3, I can go backwards by dividing by 3. 2 divided by 3 is 2/3. Divide it by 3, 2/9. Once you start getting very small numbers, then just go, oh, smaller, 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 and don't worry about it. Because there's no way you can accurately graph them anyway. All you need to know is that once you're at the y-intercept of 0, 2, you got 2/3, and then boom, just get smaller, smaller, smaller. Okay. This one, y-intercept is 1. When there's no number in front, remember that the y-intercept is 1, and the multiplier, the b value, is 2. So we double, and then we double again, and then we double again. And I can even go one more. And then that gets me right there, 1 square right off the grid. I can go backwards by dividing by 2. So -1 would give me 1/2 or 0.5, and then 1/4, etc. And again, I'm just getting smaller and smaller, so I just kind of eyeballed it. I didn't even write the dots there. I just, it's just getting smaller. Okay. So when we talk about these graphs, things that you should know as far as where are there similarities and differences. Y-intercept. This one had a y-intercept at 3. This one had a y-intercept at 2. This one had a y-intercept at 1. Okay, 0, 3, 0, 2, 0, 1. This graph was decreasing because b, 1/2 right there, sorry, yeah, 1/2, is less than 1. When a b is between 0 and 1, you will have a decreasing graph. The b value here and here were greater than 1. That's why those graphs increased. All 3 graphs have an asymptote on the x-axis at y equals 0. So none of these graphs will ever give you a y that's equal to 0. They'll just keep getting smaller and smaller and smaller values of y. They will never be 0. So every single one of these has an asymptote right here at y equals 0. So everyone has an asymptote. Okay, so those are some of the similarities and differences on those graphs. I just didn't write it out in sentences, but it did say describe similarities and differences. None of them have x-intercepts because of the asymptote. The domain on all of them is all real numbers, goes forever left to right. And then the range for all of them, for every exponential, are just values greater than 0. Okay, but again, those are some of the similarities and differences. Okay, so this is available in my notebook on Schoology, and then I need to put the other one in here. We have a new review sheet for today, and it should be on Schoology already. So you guys can open that up, and I'm going to do the same here. Just get rid of that. There we go. Oh. Got too much space in here. Okay, I'm going to insert this into my computer. But regardless, you guys can open up review sheet number 2 on Schoology, because yay, the internet is working today. That was super fun yesterday, having the internet go out at like 9:30 for basically the rest of the day. Yeah, it really wasn't fun. I was kidding. It was the exact opposite of fun. Okay, so review sheet number 2. Is here. There's review sheet number 1. And there's review sheet number 2. Wow, lawnmower sounds funny today. Okay, so number 1, 2 equations. It says if they were graphed, how are they similar? How are they different? You can sketch a graph if you want. It's not required, but you do need to be able to tell the difference between these 2 equations if they were graphed. So you got y equals 3 to the x, y equals 1/3 to the x. Okay. Number 2, we have a account that is compounding quarterly, 5% interest compounded quarterly. So we're breaking it apart here. Find the initial value, that's A, the multiplier, B, how many times are we compounding? That's the X value. So how many quarters will there be in 8 years? Write the equation and then find the value in 8 years. Okay. Number 3, in 2005, there were 1,300 cell phone subscribers in the small town of Middleville. The number of subscribers increased by 8.3% every year. How many cell phones would there be in the year 2012 or 2011, sorry, which is 6 years later from when we're starting here. Each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. So when you start, you got 128 participants. 1 round later, half of them will be eliminated. Next round, half of those will be eliminated, etc. So write an exponential equation to model the situation. And then we got some more points here. 2 points, no y-intercept. Find the exponential equation. 2 points, ooh, but that one is the y-intercept. So that makes it a little easier. Find the equation. Graph this on the graph here. Say the domain, the range, the y-intercept, where's the asymptote. And then number 7, find the equation of each curve that is shown. These are all exponential. And you will notice that, hey, there's 2 points that are listed there. So this is the same as finding the equation with 2 points, with the added benefit that you can actually visually see the graph to kind of help you know whether your answer is reasonable. So even though I can't tell you what the y-intercept is, I can see that it's like around 4, but it's not exactly on 4. So I can kind of make an estimate when I find it. If I don't get something that's close to 4, I'll know I made a mistake. Same thing here. I've got negative 2.938 and 2.384. My y-intercept looks like it's about 0.7 or 0.8. But again, you have to calculate it and just make sure you get a reasonable answer. The same thing here. I can see that the y-intercept is like 5 point something, but use the 2 points that are there and calculate your y-intercept and make sure that it is indeed reasonable. Okay, so that's kind of where we're at. Oh, I have people in the waiting room. Did not know that. Okay, so that's where we're at. So we just went over the review sheet number 1. So if you go into my notebook, you will see this for review sheet number 1 that we just went over. And then today we are working on review sheet number 2. Okay. Also for the ESA, you guys can use a note card just like the last 2 ESAs. So you can also be thinking about, well, what kind of stuff would I put on my note card? So maybe, you know, how to compound interest, growth, the 1 plus, the 1 minus, maybe an example of finding an exponential, you know, using 2 points. If that's something that you're struggling with a little bit, you can put an example of that. So just different things. The asymptote always at y equals 0. So there's just different things you could definitely put on a note card to help yourself. So as you're going through these review sheets, just be updating or thinking about what you're going to put on your note card. Okay, so I will walk around and help those of you that are here. Those of you guys online, work on the review sheet. When I come back to my seat here, you can let me know if you have questions. And I'll put my camera on so you actually